right, this is Unit 5 for pre-calc. This is Chapter 4, really sections 4.1 to 4.3. I'm going to do numbers 13 through 18 on the in-class review here. All right, so for the first one, we're given the points 6, -8, so we're going to go right 6, down 8. Draw on a triangle, so that's 6, that's -8. This is a 90-degree angle because this is on the grid. When you do your Pythagorean theorem, you get 10. Again, you should know that that's a 6, 8, 10 triangle. All right, your theta, remember, is always the angle next to the origin. So now when I fill this in, I'm going to do the sine is the opposite, so that's -8, or right hypotenuse is 10, so that's -4/5. Cosecant, you can flip it to be -5/4. Cosine is 6/10, so it's 3/5. Secant, you flip it to be 5/3. And tangent is going to be -8/6, that's -4/3. Flip it to be -3/4 for cotangent. All right, the next one, it gives that cotangent is -√3/2. To find tangent, you're going to take that and flip it, so I'll do that work right here. That's -2/√3. And when I do that, that's going to rationalize that, that's going to become -2√3/3. Multiplied by √2 on both top and bottom. All right, it tells me that this is in quadrant 2, so I'm going to draw my triangle over in quadrant 2. That's 90 degrees. Again, my theta is going to be closest to the x-axis. I need to make sure I remember that this is going to be a negative right there. All right, so that's my negative. All right, when I look at this, I have my tangent, remember here, the tangent was equal to the -2/√3. I like this one better than that version. I think this is a little cleaner. So the opposite is -2. The adjacent is the √3. So this is the 2, this is the √3, but again, that negative really is on this √3. Remember, the negative doesn't matter if it's on top or bottom there. So it's going to be the 2 over the -√3. I'm going to use my Pythagorean theorem now to solve here. So that's going to be 2 squared plus -√3 squared is equal to the r squared. R is what we use for the hypotenuse there. So 4 plus 3 equals r squared, so r is equal to the square root of 7. So now when I do my sine is going to be the opposite, which is 2 over the √7. I'm going to have to simplify that, so this is 2 over √7, which becomes 2 √7 all over 7. And cosecant, when I flip that, I'll go back to the original, just √7 over 2. All right, cosine, I'll do this in another color so you can see it. Cosine is going to be the adjacent, which is the -√3, all over the hypotenuse, which is √7. So again, that's -√3 all over √7. Multiplied by the √7 on top and bottom, so that becomes -√21 all over 7. When you flip that, I would flip this one, that's going to be a -√7 over √3. Now you're multiplying by √3 on top and bottom, you get -√21 all over 3. All right, the last 4 problems here, you're going to be plugging this into the calculator. Make sure you're in degrees for number 15 and number 17, and the radians for 16 and 18. So you plug them in, cosine of 45 degrees. All right, it says round to 2 decimal places, so I prefer to round to 3 decimal places, so I'll do it actually both ways here. So 2 decimal places is 0.71. I would prefer that we round to 3 decimal places and make that 0.707. All right, I'll just jump to 17 since you're going to do that in degrees next. So the sine of -270 here is just going to give you 1. All right, number 16, you have cotangent of pi/3. Remember, when you do cotangent, you're going to type this in as 1 over tangent of pi/3. Make sure you flip the calculator radians. And this one I have is 0.58. I don't have the 3 decimal version for that one. And then number 18, secant. Secant matches up with cosine, so it's going to be 1 over cosine of -pi/2. All right, when I do that, the answer here is going to come out to be undefined. All right, let's talk a little bit more about why that is. Remember, cosine -pi/2. So -pi/2, if you were to graph that, here's your initial side. -pi/2 is going to be down here. This point is going to be 0, -1. So cosine is the x values. That's this one right here. So it's 1 over 0. 1 divided by 0 is just going to give me the undefined. So that does work out.